Welcome to methamphetamine. Today we are going to do the integral from 0 to infinity of lnx divided by 1 plus x power 4. And this is the second method. We are going to do this integral by our second method. And from the last video, you can see the result to this integral is equal to negative pi squared times square root of 2 divided by 16. But by my hobby, I always want to write the result as our irrational version. Like, I don't like the rationalized version of the result, so therefore I'm going to write the irrationalized result here. Negative pi squared divided by a times square root of 2 here, like that. So what's our method 2 to this integral? So let me just show you. First, we have a formula here. We are going to use this formula soon, which is just the integral from 0 to our infinity. From 0 to infinity of our ln x divided by x squared plus a squared here. So first thing, we are going to find what is the result to this integral. So first, we are going to use our substitution. Because you see that x squared plus a squared here, we are going to use the trigonometric substitution here. Let our x is equal to a tangent theta. Our dx is gonna be our a times secant square theta d theta. And then you can get theta is equal to inverse tangent x divided by a here. And here, 0. Inverse tangent of 0 is 0. Inverse tangent of infinity is pi over 2 here. And then the constant a, you can put it outside the integral, a. And then secant square is here. Secant square theta is here. Time ln x, which is equal to a times tangent theta. And then the bottom, we are going to get our x is equal to a squared tangent square theta. And then we can just factorize the a square here. You can get a square times tangent square theta plus 1 here. We know that tangent square theta plus 1 is equal to secant square theta. So we can just cancel this two things out. And then also cancel this and this. So we can put our 1 over a outside the integral. And then times ln a tangent theta. Yeah. Here, we're going to use the product rule, the addition rule. Product ln, we get addition, like that. Ln a plus ln tangent theta. So we can just split to two different integrals. Ln a in our integral, we can just put it outside the integral because this is a constant. Time 1 d theta. And then plus 1 over a times the integral from 0 to pi over 2 of ln tangent theta. We know that the result to this integral is equal to 0. So if you want to see the proof here, you can check my other videos of it. But I don't want to waste much time here, so let me just save more time. I don't want to waste too much time. And then the integral of this, which is pi over 2. So you can get pi times ln a over 2a, like that. Here, the original integral is here. Let me write it down. We trying to use this formula. This is a power 4. And the formula here is x squared, which is power 2. How can we do this? So first thing first, I'm going to switch the order of this because x squared, x power 4 plus 1 is just the same as 1 plus x power 4, right? And then I'm going to use the partial fraction here. First thing, we are going to use the I kind of forget what it's called. Factorization, right? Factorization, yeah. We are going to factorize x power 4 plus 1 here. First, we are going to to factorize, we must use our negative side here. We must have a negative side here. And then we are going to write this x power 4 as x squared and then square. But how can we do this here? We want another square here. 1 square isn't the same as positive 1. Therefore, we are going to use the imaginary number here, I square here, like that. Negative I square, which is just positive 1. Match the original question. Here, after using our partial fraction, you can get this is equal to x squared minus I times our x squared plus I here. Here we are going to use the partial fraction here. X squared plus I minus our x squared plus I. X squared cancel each other out, and then I. We have double I here, which is adding up to 2I. We must divide by 1 over 2I. No, we must divide by 2I here to match the original. Question. Here, we are going to split it to two different integrals. 1 over 2I times the integral from 0 to infinity of this and this cancel out. You can get ln x divided by x squared minus I. And then switch the order. Factorize the negative side outside. You can get negative times x squared minus I. Cancel this out. You can get minus 1 over 2I times the integral from 0 to infinity of ln x over x squared plus I here. So we have finally used this formula here. To match with the positive side, we must get a positive side here. Positive negative I. Take square root of this and then square this. Like that. This one pretty much just do the same thing. Plus our I square. Don't forget about the square root to make the original correct. I square like that. This square root of I square. How? Okay. We know the result to this, which is pi ln a over 2a. Pi ln root negative I over 2 times negative I. And then minus 1 over 2I times pi over 2 times our ln I root I divided by our wait a minute. Pi times ln root I over 2 times root I, like that. Here, I'm going to factorize the pi over 4i, and then here, because of the power rule, this is negative I power of 1 over 2, and then this is I power of 1 over 2. Because of the ln rule, you can put the 1/2 outside. Factorize the 1/2 once again. 1/2 times pi over 4i, which is just pi over ai times ln negative I over root negative I minus root I ln I, like that. Here, we know that ln negative I, which is equal to our negative ln negative I is equal to negative pi over 2i, like that. And now ln I, which is equal to positive pi over 2i. And then we are going to factorize the negative side outside. You can get negative pi squared, and then I and I, they cancel each other. You can get pi squared over our pi squared over 16. Right? Am I right? Yes. And then the last thing we are going to complete this. Don't forget about we factorize the negative side, so this positive side here. this plus this here. So what can we do? Here we pretty much just multiply by, just cross multiply. Therefore, this times this, I times I is equal to -1. Plus another negative side, you get 1 here. 1 in the denominator, pretty much just ignore it. And then you can pretty much just get root I plus square root of -I. And then remember the formula to this, which is equal to, the root I is equal to 1 over square root of 2 plus our I over square root of 2. And then this one you can get plus our square root of -I is equal to 1 over square root of 2 minus I over square root of 2. You can see the cancellation here. Therefore, we just get a result here, which is equal to -pi square over 16 times square root of 2. No, just joking. Please be careful. 1 plus square root of 2 plus 1 over square root of 2, which is 2 over square root of 2, which is just square root of 2. So you can get the same result as the method 1. This is the irrationalized version. You can write this as our, this is the rationalized version. I'm going to write it as our irrationalized version here, which is -pi square over 8 times square root of 2. And this is just our result. And thanks for watching this video, and bye.